Hello. In this example, we want to set up but not evaluate the integral needed to find the volume of the solid obtained by rotating the region bounded by y equals x cubed. So that looks like this. Y equals x. It's a line. And x bigger than 0. So this little area here is repeated to the left of the y-axis, and we're not caring about that when we rotate about the x-axis. So we get a reflection when rotating about the x-axis. And we're looking at this volume that on the outside looks like a cone, but on the inside has curved edges showing in. Not quite an ice cream cone shape, but cone on the outside with this curved edges going in. We want to find the volume of that shape. We're going around the x-axis. So the disks method says we're going to be in terms of x, and we're looking at pi times the function squared dx. And in the last video, we had the idea of the washer method, which is pi integral of the big radius squared minus the little radius squared. And if we're looking here, because we're getting this hole in the middle of our solid, we are going to be using that washer method, where since we're going around the x-axis, that is what is right at the center of our washer. This is y equals 0. And then we're going to find from y equals 0 out to our first function, and then from y equals 0 out to our second function. We're looking at our picture from the x-axis out to our functions. The first thing we hit is the cubic function, the y equals x cubed. So that is our small radius. And then the farther radius is from the x-axis up to the line y equals x. So our big R is r equals x. So filling in this integral that we don't need to evaluate, we just need to fill in. We have that the volume is pi times the integral of our big radius squared minus our little radius squared dx. The last thing we need is these bounds, which it is pretty well known, but we could also solve for when x equals x cubed, that for x being greater than or equal to 0 will happen at x equals 0 and x equals 1. So our bounds are 0 to 1, and simplifying this integral a little bit, we have the integral of pi times x squared minus x cubed dx from 0 to 1. That integral will find the volume of that cone-like solid.